Hello everybody, welcome back to another video, and in this video we're going to be taking a look at a question from the IB Chemistry HL paper 2 from the November 2018 batch. Now, this question asks us 3.26 grams of iron powder are added to 80 centimeters cube of 0.2 mole dm cube of copper 2 sulfate solution. The following reaction occurs, and they've given us this word equation over here, not the word equation, I mean the chemical equation of the reaction. And they've asked us in the first part, determine the limiting reactant showing your working. Now, in order to first understand what they're asking us to do, it is very important to know what the limiting reactant is, or what a limiting reactant is. A limiting reactant is the reactant in a chemical reaction which is consumed entirely or which is in deficiency. So what I mean by that is that it is the reactant which basically determines how much product is going to be formed because it's less than the other reactant in less quantity than the other reactant. Now I'm going to give you an example to make you understand what I'm talking about. Imagine you have four, these are four burger patties. Okay, so I'm a fan of food, so I'm gonna imagine that these are four patties of burger. Okay, so they are burger patties. And you have burger buns as well. So you have five burger buns. So just imagine these are burger buns. I know they look nothing like them, but just imagine that they are. So these are your burger buns, and you're preparing food for a party, and you have five burger buns. Now, in order for you to make a burger for your guests, you're going to require burger buns and you're going to require burger patty and maybe a sauce and vegetables if you would like to add that. So, anyways, in this case, the maximum number of burgers you can make, proper burgers for your guests, is only four. You can only make four proper burgers. Why? Because despite you having this one extra bun over here, you actually can't really do anything with this. You can't make a burger out of this because in order to make a burger, you need these two things. You need a patty and you need a burger bun. And you have four patties, but you have five burger buns. So you can only use four of those burger buns to create your final product, which is your burger. And then this burger bun over here, which is left, is the excess. It's an excess, right? You can't really do anything with it because you don't have your patty, so you can't make a burger out of it. So it's an excess. Whereas your patties over here, this is your limiting factor. This limits how many burgers you can make because you have an extra burger bun, but you can't make five burgers because you have only four patties. So this is you could think of this as your limiting ingredient. Now, there's a very similar case in this question as well when they ask you to determine the limiting reactant. So which of out of these two, which is the limiting reactant, meaning which determines how far the reaction proceeds or how much how much of the final product is made, right? Which of these determines that? And the substance which determines how much product will be made is the substance which is in the lesser quantity. So in the case of in the example of our burger patties and burger buns, our burger patties were the limiting reactant, right? Because they determined how many burgers could be made in the end. Only four can be made. And similar to that, we have to figure out which is our burger patty in this example, taking it metaphorically. So let's determine which is going to be our limiting reactant in this question by finding out the quantity of both reactants, which is the iron powder and the copper sulfate solution in moles. Because remember, that is how we compare how much substance there is or what is the quantity of a certain substance in chemistry. So we have to first convert we have to find out the number of moles of both these reactants. So how do we find the number of moles? Well, they have given us all the necessary tools to find the number of moles in the question itself. They've told us that 3.26 grams of iron powder is added to 80 centimeters cube of 0.2 mole DM cubed copper 2 sulfate solution. So we can actually find out how many moles of iron powder there are by just looking at the grams, the mass in grams. So we know that number of moles is equal to mass of the substance over the molar mass of the substance. Sorry, small m over big M. So in this case, we know that we have 3.26 grams of iron powder, and the molar mass of iron, which you can find in the data booklet, is 55.85. And this gives us the number of moles as 0.058 moles. So this is how much, these are the number of moles of iron powder that we have. Now let's find out the number of moles of the copper 2 sulfate solution. Now, of course, there's no space here, so I'm just going to work it down over here. Now, the copper 2 sulfate solution, it's a solution, right? So then how do we find the number of moles of a solution? And the formula for that is the number of moles of a solution is equal to the concentration of the solution times the volume of the solution. But the volume has to be in dm cubed. It cannot be in anything else. It can't be in cm cubed. It can't be in anything else. So it should be in dm cubed. So we know what the concentration is. We know that the concentration of the solution is 0.2 because they've told us that. And the volume, they have told us that in centimeters cubed. So in order to convert centimeters cubed into dm cubed, we have to divide by 1,000. So we do 80 divided by 1,000. So we can cancel out. So this equals to 0.08. And 0.08 times 0.2 is equal to 0.016. So that's how many moles of copper sulfate solution we have. Now, if we compare the number of moles of iron powder that we have to the number of moles of copper sulfate solution we have, we can see that the iron powder is in excess because 0.058 is more than 0.016. And that would mean that our copper sulfate solution is indeed the limiting reactant. It determines how much product can be formed. No matter how much excess iron we have, it doesn't matter because you need copper sulfate solution for the reaction to go ahead. So only the number of products or the amount of products that you gain is purely dependent on the amount of copper 2 sulfate solution or the number of moles of copper 2 sulfate solution that you have. That's why it's called a limiting reactant, because it's in deficiency. So that is generally, or that is the way you determine what the limiting reactant is. And I hope that I have helped you to understand the concept behind what a limiting reactant is and so on. So I'm just going to erase this and I'm going to write the answer here. So determine the limiting reactant. I showed you the working and we know that the limiting reactant is CuSO4, right? But remember in the exam, show all the working in the box. If it gets messy, take an additional sheet of paper and do your working on that, but make sure you show it because otherwise they'll cut marks. They need to see you doing the working. Now let's move on to the next part of this question. It asks us, the mass of copper obtained experimentally was 0.872 grams. Calculate the percentage yield of copper. Now, in order to calculate percentage yield, remember this formula. So percentage yield, I'm going to call this PY, percentage yield is equal to the mass of the substance, which is, mass of substance, which is derived experimentally. I'm just going to call this EX, experimentally, divided by the mass of substance found out theoretically, and multiply this by 100. Sorry, forgive me for that. Now, what does this mean? So this is the formula of percentage yield, but what do these terms mean? So the mass of substance which is derived experimentally, that they have told us in the question. So maybe a student named Dan conducted an experiment where he adds 3.26 grams of iron powder to copper 2 sulfate solution, which has a volume of 80 centimeters cubed and a concentration of zero point 0.2 mole dm cubed. So he conducted the experiment, and the mass of copper that he obtained, which is his product over here, the product that he obtained, the mass was 0.872. But if you were to do this on paper, meaning if we were to find out how much copper is going to be produced by just looking at the number of moles of the limiting reactant, if and then finding out how many moles of copper can be produced, we can actually we'll see that the theoretical value, meaning the value that is done on paper, is not the same as the experimental value or the experimental mass of the copper derived. Now, why does this happen? This happens because there are so many things that are different when you are calculating something theoretically, and there's so many things different when you're actually doing it in an experiment. In an experiment, there are things which are different. In real life, things often don't work out perfectly, right? Because you could have experimental errors, you could have systematic errors, random errors. Your substance could not be pure. Maybe your substance has some impurities which causes you to have a lower yield, and so on and so forth. So there are many things that can go wrong while doing it experimentally. And the theoretical value is the absolute best case scenario, or the ideal scenario of the amount of product that you obtain in an experiment. So it's the best case, the ideal scenario. But unfortunately, in real life, we don't have the ideal scenario. It doesn't always work out to be ideal. So in order to determine the percentage yield, we have to first know what is the experimental, how much have we got out of the experiment itself, and what is the ideal value, or what is the theoretical value that we ideally should be getting, but we won't necessarily get it. But what is the value that we should be getting by calculating it on paper? So how do we determine the theoretical value? Well, the theoretical value is, well, calculating it on paper. So if we were to see how much of the product, how much copper we should obtain by this reaction, we can determine that because we know the number of moles of the limiting reactant. The number of moles of the limiting reactant was 0.016. If you remember, I did the calculation earlier. And we see that Cu2SO4 and copper are in the 1-to-1 ratio. That means that for every 1 mole of copper 2 sulfate solution, 1 mole of copper will be produced. So for every 0.016 moles of CuSO4 solution, we will also produce 0.016 moles of copper. And we can calculate the mass of copper that should theoretically be obtained by using the formula. So we know the number of moles, which is 0.016, and this is equal to the number of the mass. I'm going to put that as X because I don't know what X is. This is what I'm trying to determine. And I know the molar mass of copper, which can be found in the data booklet. The molar mass of copper is 63.546. This is nothing but the N is equal to M over M formula. This is the exact same thing. I've just substituted the values in because now I know what N is. I know the number of moles. I know the molar mass. I'm trying to figure out the mass. So I'm just rearranging the equation. So now we can solve for X. So X would equal to 0.016 times 63.546. And this gives us a mass of copper of 1.016 grams. So the theoretical value, so theoretically, we should be getting this much copper, or this amount of mass, or yeah, the mass of copper that we should be getting in the experiment should be this much. However, as you can see, it is not the same as the experimental value. Our experimental value is less than our theoretical value. And as the reasons I had given you earlier about why there's a difference between the experimental and theoretical value, that explains why the experimental value is the mass of copper obtained experimentally is lower than theoretical value. So let's just implement all these values into our percentage yield formula. So percentage yield is mass of substance derived experimentally. So that's 0.872 divided by the mass of substance derived theoretically, which is 1.016, and multiplied by 100, because we're trying to figure out the percentage, and in order to figure out the percentage of anything, you always have to multiply it by 100. So that will give us a percentage yield of approximately 85.76%. So that is a percentage yield. So that's a pretty good percentage yield. And why is it necessary? Why do we calculate percentage yields? What's the purpose of this? Now, I want you to imagine yourself being a person who works in the chemical industry where you manufacture a certain amount of chemicals, and you're a businessman, right? You want to make a lot of profit, and you want to make as much profit, or in order to make a good amount of profit, you need to reduce your expenditure in the amount, or you need to reduce your expenditure during the manufacturing process. So if you are a person who manufactures copper, you want to figure out what is the best method to make copper, which gives you the highest percentage yield. This percentage yield basically means which method to produce copper uses the least, gives you the most efficient reaction. Because if a reaction is not efficient, meaning if suppose the percentage yield of this reaction was 40% instead of 85.76, it wouldn't be a very efficient reaction, because theoretically you are supposed to be getting something, but experimentally you're actually getting a much lower value. So this reaction is quite efficient because you're getting a you're getting a experimental value which is pretty close to your theoretical value. So that is just one of the applications of percentage yield. I hope you understand what I mean. And thank you for watching this video. If you have any questions regarding this concept or any other concept, please feel free to reach out to me on my social media, or send me an email, or put it down in the comments below, and I will be more than happy to help you. Thank you so much for watching. I'll see you in another video with another question.